Grüezi YouTubers, here is the guy with the Swiss accent. If you plan to start with LoRa and do not want to spend lots of money, you can start with an Arduino Uno and a Dragino shield for around $20 and connect it to the nearest gateway. In episode number 117, I built such a node. But if no gateway is around your location, then you can build your own full-blown public gateway as I did in episode number 115. This costs you around $300, which is way too much for most of us. Today we will build a gateway for much less using an old Raspberry Pi and a LoRa hat. The hat is around $30 and the whole gateway is quite simple to build. And I will show you its limitations and what you have to do to avoid problems. In parallel, we will learn a little more about the LoRa protocol. So let's get started with assembling the hat and the Raspberry Pi. This is straightforward. I use a small brass stand to make it more stable. This hat also has a GPS module, but today we do not use it. After assembling the hat and the Pi, we have to create an SD card with the needed software. We start with an SD card with an installed Raspbian chassis release. You find a link in the description on how to create such an SD card. Now we can start to set up the rest. You also find a link with a tutorial on how to do that, and I will follow this document for the next steps. The tutorial does not use a Pi hat. It just uses the bare RFM95W module. This is also a possibility if you want to save another $20, which is the difference between the Pi hat and the bare module. According to the instructions, you first have to clone the repository of the gateway software. Then we have to enable SPI, if not already done. Next, we have to install Wiring Pi. This software enables the possibility to control the various GPIO pins of the Pi. In the next step, we have to adjust some constants in the main.cpp file. Please check first the pin assignment. Then you change the server address, the frequency your gateway will run on, and the latitude and longitude of your gateway. I use here 868.1 MHz, but you can also use 868.3 or 0.5, which are the three mandatory channels for TTN. Then you make the executable file and start the gateway software. Be aware that your gateway only works as long as this program executes. If you press Ctrl+C, the program stops and your Pi is no more a gateway. Right at the start of the gateway software, you get the unique number of your device. This will be needed to connect to the TTN network later. So write it down and remove all columns. Now you go to the page of TTN and create an account, if not already done. Then you enter the management console and register a new gateway as packet forwarder. Key in your gateway number from before and enter the frequency plan. If you did not enter the position of your gateway in the main.cpp file, you have now a chance to enter its position here. After registering the gateway, you should see status connected and a small number of seconds in the field last seen. That's all. Your gateway is now ready and can receive and transfer messages. Now, apart from the price, what are the differences of the expensive gateway on my roof compared with the one in my lab here? There are three main differences. First, my small gateway here, as its name says, has only one channel. 2, it can only deal with one spreading factor at a time. And 3, currently it has no downlink possibility. However, this is not a hardware limitation and maybe once somebody will enhance the software to include this feature. So let's play around with it to discover if these differences really matter. To do that, I have here my LoRa node from episode 117. It sends every minute a message. Let's see now on the TTN console what happens. The first message sent by the node arrives and we see that it was received by both gateways. Great! Our small gateway works. The signal on the roof was, of course, much weaker, but still acceptable. Spreading factor was SF7. The next message, however, did only arrive at the gateway on the roof. Why is that? I did not change anything and the signal should be very strong. So this cheap gateway does not seem to be very reliable. Let's give it a second chance and we wait for the next message. And also here, it is not received by my new gateway. So, I give it a last chance. Maybe it knew that it was its last chance. This time, it transferred the message. So, this small device is not very reliable. Should I throw it directly into the trash bin? Was this just a joke? If we have a close look at the transmission frequencies, we see that the node changed it with every message. This is a good behavior. If channel 1 would be disturbed, for example, we would get at least the next message on the channel 2. But we said before, our single channel gateway was only compiled for channel 0. So it did not hear the signal on channel 1 or 2. And we have at least an explanation of its behavior. But how can we deal with that? Let's assume our node would always send its messages on channel 0. Then our new gateway would receive all messages and we would have resolved this issue. But what kind of other problems do we cause by that? For a productive environment with hundreds of nodes, the concept of frequency hopping is useful. But if you just want to test the technology or use it around your house, then you only have a handful of sensors, and this frequency hopping is not absolutely necessary. So we just have to find a possibility to switch it off in our node software. This is easily done by this command. We just disable all channels we do not want. For Europe, these are channels 1 to 8. Now all messages are sent on channel 0, which is 868.1 MHz. So we have now a gateway for our own use. And even our neighbor can use it if he constrains his node to just our channel. No problem. Just to show you that the gateway can only receive one spreading factor at a time, I change my node to SF12 and the message is not received, even on channel 0. So we also have to make sure that the nodes and the gateway uses the same spreading factor. So summarized, we built a simple and less expensive TTN gateway with a Raspberry Pi and a LoRa hat. The software is easily to be installed and adapted. If we make sure that our node only uses one channel and one spreading factor, this setup is very usable for our own purpose. The capacity of such a node is good for at least 20 concurrent sensors or more, depending on the sending patterns. And the best? Because we are now connected to the TTN network, we can profit from other things. For example, we easily can connect our devices to our Node-RED installation. A TTN node already exists, and we can connect our device straight to Node-RED. At the end, we see here, as an example, the frequency of the transmission and the RSSI values of both gateways. With this, you can now attach your sensors or also buttons via LoRa and TTN to your home automation system. Great! I hope this video was useful or at least interesting for you. If true, then like. Bye!